Hi there, I'm Chris Saxon, the SQL Wizard, and today we're going to take a SQL look at a classic card trick, the 4 jacks. However, we're not just going to have the code in this one, we're going to have the live cards side by side with the code. Excited? I am. Let's get started. Once upon a time, there were 4 brothers, all of whom were named Jack, and they lived together in a house of cards, along with all their friends. One night, the 4 Jack brothers decided to go out for a drink. Jack of hearts, Jack of clubs, Jack of spades, and the Jack of diamonds. They went out, leaving everyone else behind. While they were out, they got into an argument with an ace. They quickly rushed back home, in through the front door, and then hid themselves throughout the house. The first one went into the basement. The second one went into the kitchen. The third one went into the bedroom. And the final one hid in the loft. They squirreled themselves away, thinking they were safe. Unfortunately, they forgot to lock the front door, and the ace was able to come in after them, scaring all the other cards off in the process, leaving the 4 jacks to face the ace by themselves. That was fun! If you want to know how the real trick was done, you'll have to Google that yourself. However, to see how I did the SQL version, stay tuned while we take a look behind the curtain. At the end of the trick, I deleted 47 rows out of the table, leaving just the 4 jacks and the ace of spades. The question you're asking yourself is, well, how did I know I'd leave those 5 rows and not any other ones? To understand that, let's take a quick look in the schema browser. We expand it out, you'll see this different looking icon next to the card trick table. This means it's an index organized table. Index organized table? What's that, I hear you ask? Well, in a normal table with a primary key, there's 2 data structures, the table itself and the index supporting the primary key. In an index organized table, those 2 data structures are collapsed into one. The primary key index is the table. Now, indexes are ordered data structures. This means that the row with the primary key value 1 is next to the row with the value 2, which is next to 3, which is next to 4, and so on. Now this is all very well and good, but you may be saying, well, if card ID is the primary key, how did I end up with rows 0, 13, 26, 39 and 52? Why don't we have the rows 0 through 4 or 48 through 52? To understand that, let's take a look at the table definition. Here's the script I used to create the card trick table. You'll see the 3 columns you're already familiar with: card ID, val, and suit. However, there's one here you've not seen before, a secret column. Why doesn't this appear? Well, I've designated this to be invisible. This is a feature introduced in Oracle 12c. Invisible columns don't appear when you issue a select star against the table. To see the values stored within them, you need to explicitly reference them in the select clause. And it's this secret column that I assigned to be the primary key of this index organized table. To understand what's going on, let's run through the trick again, this time including the values from the secret column. At the start of the trick, the jacks have primary key values which are negative. All the other rows have secret column values equal to the card ID. This enables the jacks to be sorted at the top. We'll then delete the jacks and the ace of spades and reinsert the jacks. And at this point, the jacks now have new primary key values. The secret values match the card ID. This scatters the jacks throughout the table. So how did I get them to be all next to each other? Well, let's take a look at what happens after we insert the ace of spades. We put that in and Ta-da! The jacks and the ace are all at the bottom, and they've got new secret values. They've got characters at the start. This means they're sorted after all the numbers for the existing rows. How did I do that? With a bit of trigger trickery. If we take a quick look at the table definition and the triggers, we see that if secret doesn't have a value, just set it to be the card ID, unless it's the ace of spades. In this instance, prepend ace before the card ID. And then there's another check. If we got the ace of spades, add a J before the card ID in the primary key for all the jacks. This sets the secret column values as we see here. This means that when we issue the delete here, we're deleting these other 47 rows. Let's just do that, and we can see we're left with just the 4 jacks and the ace of spades. Using an index organized table enabled us to have the 4 jacks and the ace of spades right next to each other in the database. It's made for a cool magic trick, but what practical applications does it have? Let's take a look at a couple. First up, master detail relationships. These are things like orders to order items, invoices to invoice items, travel itineraries to all the flights contained within them, students to all their exam grades. These are situations where you'll typically fetch all the rows in the child table for a given parent row. For example, when you access the database to ask for an order, you typically want to get all the products that are contained within it at the same time. By creating order items as an index organized table with the order ID as the part of the primary key, you can be sure that all those items are physically located near each other, minimizing database I/O and improving the overall efficiency. The second point is index organized tables combine table data and index data into one structure. With typical heap tables, you have your data stored in your table, and you'll also have it stored in your primary key index as well, duplicating storage requirements. By using an index organized table, you reduce this. This is particularly useful for narrow tables, such as lookup tables where you have a primary key and maybe a description, or many-to-many join tables where all the columns form the primary key. By creating these as index organized, you can save yourself storage by just having one data structure. That was our SQL version of the classic 4 jacks card trick. We saw how we combined invisible columns with index organized tables to get those 4 jacks to squish together into the same location in the database. IOTs are a technique you can use to improve the efficiency of queries against tables with multi-column primary keys, where you typically fetch all the rows based on the leading column in the primary key. I'm Chris Saxon. Thanks for watching. Thanks for watching. I'm Chris Saxon, the SQL Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.